Hi everyone, welcome to Learn Awesome. In this video, we are going to build a React Todo app completely from scratch, step by step. And we'll be using React hooks like useState, useEffect, etc. to manage everything. No class components, no external libraries, and no backend, just pure modern React. This is a beginner-friendly project, so if you are just getting into React or you want to level up your skills with a real-world example, you're in the right place. We have a React crash course on our channel as well, and I'll drop link in the description. So here's the cool part of the project. Your to-do list will be saved using something called local storage. This means even if you refresh the page or close your browser, your task will still be there. So by end of this tutorial, you'll understand how to manage state in React using useState, how to save data to the browser using local storage, and how to build a clean functional UI. So let's jump in and get started. Right, so let's get to what we are going to build today. So we are going to follow 6 simple steps. In first step, we're going to set up the project, build the UI with JSX, add interactivity with useState, make to-dos editable, and save them using local storage. And we are going to style everything with CSS. So let's get started with it. So, all right, let's set up our React project. We'll be using a tool called Vite to create our React app. Vite is super fast and beginner friendly. And it's becoming a new standard for starting modern web projects. Don't worry if you have never heard of it, I'll walk you through everything. So make sure to have Node.js installed. You can download it from nodejs.org. Open your terminal or command prompt and follow along. So let's create our React app using Vite. So just type this. This command says, hey npm, use Vite to create a new project called React Todo App and set it up using the React template. So it's going to ask a couple of questions. Okay to proceed. Of course, yes. We're going to select React here. And since unfortunately we are not using TypeScript here, so I'm just going to select JavaScript. And done. Vite has set up everything for us. Next, we need to go to the project folder. So if you look at the project folder now, we have the package.json and other things available. We need to install them though, so we are going to issue the npm install command. This might take a few seconds. It's installing React, React DOM, and some dev tools Vite needs. Okay, it's done. So we need to open the project in Visual Studio Code now. So I'm going to use the command code dot. Right, here we are. This is the package JSON. And if I go to source, it has created a boilerplate Vite project, which we are going to preview now. So now we are ready to start the development server that will launch the app in your browser so you can see changes live as we code. So for that, I'm going to open the terminal over here and issue the command npm run dev. And there we go. Vite gives us a local server link right over here. If I click it or open the same URL in browser, we can see the default Vite plus React welcome screen from the boilerplate project. Right, let's have a look at the files Vite created for us. So here's index.html. This is the HTML file our React app is injected into. Then we have under source folder, we have main.jsx. This is where the app starts. It tells React to render our app component. Then we have app.jsx. This is the main component we'll be working in. And app.css is where we can use to create our own styles. We'll keep things really simple. We'll do everything in app.jsx for this project to keep it beginner friendly. Awesome, you have just set up a modern React project using Vite, installed all the dependencies, and got it running in the browser. In the next section, we'll start writing real code, building the UI, and adding functionality to our to-do list. All right, now that we have our project running, it's time to start building our to-do app UI. We are going to keep it simple and clean, just a heading, an input field to give you a new task, a button to edit, and a list to show our to-dos. All of this will go inside app.jsx, which is our main React component. First, let me clear out the boilerplate code Vite has injected in here to give you a clean slate. And now I'm going to write from scratch. Let's go through what we just wrote. At the top, we are importing useState from React. We'll use this soon to keep track of our to-dos. We also import app.css so we can style our app later. Then inside our app function, we return some JSX. JSX looks like HTML, but it's actually JavaScript under the hood. We've got a div with a class name app. Inside it, a h1 heading that says to do app, then a container with an input field and a button. The user will type a task here and click the button to add it. And finally, an empty, unordered list, UL, where our to do items will appear. If we check our browser now, you should see the heading, input box, and button. But it looks a bit plain. That's okay, we'll add some CSS styling later, but first let's make this app actually work. If you're new to React, here's something important to know. You can only return one top-level element in your component. That's why we have wrapped everything inside one div. Class name in JSX replaces class in HTML because class is a reserved word in JavaScript. Every component in React is just a function that returns some JSX. Right, so far we have set up a clean layout, added an input and a button, and set the stage for displaying to-dos. In the next section, we'll start writing our React logic using useState so we can actually add tasks and display them in the list. Alright, let's make this app actually do something. We want to let the user type a task, click the add button, and show that task in the list below. To do that, we need to use something called state in React. Let me explain. In React, state is how we remember things in our component. Imagine a variable that changes when the user interacts with your app, like typing in an input or clicking a button. In regular JavaScript, we use variables, but in React, we use a special function called useState. Let's see how that works. So what does that mean? We are using useState to create two pieces of state. Task is a string that holds whatever the user types into the input field. To-dos is an array that holds all our to-do items. SetTask and setTodos are functions we use to update those values. Now let's connect the input field to the task state. We'll make it a controlled component, which means React is in charge of what's in the input box. Alright, now every time the user types, we update the task state using setTask function. Let's break this down. Value equal to task makes the input reflect our state. And onChange E set task updates the state as the user types. If it's not clear yet, it would be when we see this in action. Now let's write the function that runs when the user clicks add. This will take the task from the input, add it to the to-dos array, and reset the input field. Right, let's walk through this. So first we check if the task is empty using trim. If so, we skip it as we don't want empty tasks floating around. Then we create a new to-do object with a unique ID, which we are assigning date.now or a timestamp, the task text, and a completed flag we'll use later. We use setTodos to update the to-dos array. ..todos means keep the existing ones and add a new entry. Finally, we reset the input field with setTask so that our input controller is cleared out. The final touch is to update the button element itself to leverage that function. Now when the button is clicked, our handled add to-do function runs and add the task to the to-dos array. Alright, so we have done most of the heavy lifting, but it's all worth nothing if we can't see the list of to-dos. So let's work on that next. So I'm gonna get rid of this placeholder comment and do the real thing. Alright, remember to-dos is an array, and we are using .map to loop through our to-dos array, and for each entry, we show a list item with the text property of to-do. We also add a unique key using todo.id. React needs this to keep track of list items. So time to go ahead and try it in the browser. Awesome, isn't it? We are typing the task, pressing add, and they're showing up in the list as we do that. Right? So you have now built a real-time interactive React app. And don't worry if it looks ugly, we'll fix it later on, one thing at a time. Alright, so far you have learned how React State works with useState, how to create a controlled input, how to add items to an array in React, and how to render a dynamic list with .map. Next up, we'll make this to-do list even better by adding functionality to mark tasks as complete, delete them, and then we'll store everything in local storage so it persists. If you have made it this far, give this video a quick thumbs up if it seems useful. So nice work so far, viewers. Right now, our app can add tasks, but we want to go a bit further. So in this section, we are going to mark tasks as completed, delete tasks, and save everything to the browser using local storage so our list doesn't disappear when we refresh. This is a very exciting section as you can see, so let's get started. Let's first add the ability to mark a task as done. For that, we'll add a button next to each task, and when we click it, we'll toggle a completed property. To do that, we are going to manipulate the list item property. So here we go. All right, here's what we have done. We added a small tick button beside each to-do. We are enclosing the Unicode character code in string and curly braces to let JSX process it as JavaScript expression. Otherwise, it would get written out as is in the browser. We used inline styles to apply a line through if the to-do is marked as completed. And we'll create a function called toggle complete to handle the logic. This function loops through all to-dos using .map, and do recall that to-dos is a state variable in our React component of type array. If it finds the one with the matching ID, it toggles the completed property using not todo.completed. Then it updates the state with set todos and pass in update todos as argument. Now here's something really important, especially if you are new to React. We are not directly changing the todos array. Instead, we are creating a new array called update todos and we pass that into set todos. And here's why. In React, we always want to avoid mutating state directly. That means we never want to just do something like to do 0.completed equal to true, even if it seems to work. That would bypass React. React might not detect that change properly, and the UI might not update the way you expect. By using .map to return a new array, we are telling React, hey, there's a brand new version of our data. Go ahead and re-render the UI based on that. So do remember, always create a new array or object when passing to the setState function and never mutate existing state directly. That's why we are calling setTodos with updated todos. We give React a brand new array and now it knows exactly what changed. Alright, next let's allow users to delete tasks. For that, we again update our list item to include a delete button. We now have a delete icon or trash emoji and we'll write a delete to do function shortly. And if you are wondering why we made a crazy syntax even crazier for Unicode character, it's because trashcan emoji is an extended Unicode character which are defined as Unicode characters beyond FFFF. If you don't like it, just use the character X instead. That would work perfectly fine. Next, we need to add delete to do, which we would be adding after toggle complete. Alright, this function uses .filter to remove the to-do with the matching ID from the array and creates a new array. Then we update the state again using set to-dos and pass in the new array. Right now, if we refresh the page, everything disappears. So let's fix that by saving our to-dos to something called local storage. Local storage is built into your browser. It lets us save small amounts of data permanently, even if the user closes the page. For that, we are going to use useEffect hook to load to-dos from local storage on app start. So this use effect runs once the component loads. It tries to get the to-dos from local storage. If it finds them, we use set to-dos to load them into state. And we wrap it in json.parse to convert from string to array. I am assuming you are aware of the useEffect syntax already. The first parameter is the function that would be executed when this useEffect is triggered. The second parameter, which is dependency array, would ensure the hook runs when the given dependency changes. At the moment, we are passing an empty array, which means the useEffect hook would execute only once when the component loads. Empty array is special, so do keep that in mind. Next, I'm going to add another use effect, which is going to save to-dos to local storage when they change. This effect runs every time the to-dos array change. It saves the updated array to local storage using local storage.set item, and we convert it to a string with json.stringify. And I am assuming you do realize that this is going to execute every time we make any call to set to-dos. Time to test this in the browser, making sure the file is saved. All right, let me mark one of the tasks as completed. Perfect. I can undo the change. Let's keep it as completed. Let's delete one task and let's refresh the page so to make sure our local storage thing is working. Everything is gone. That's not supposed to happen. We are saving to local storage, but it's like the data vanished. Let's break it down because this is one of those moments where React feels like it's pulling a prank on you. So when the app first loads, our to-do state starts as an empty array because this is the default value specified here for our to-dos array. The no dependency use effect executes next and reads from local storage. It finds all the stored to-dos and puts them in the stored to-dos. We then call set to-dos with the stored to-dos non-empty array to load the saved to-dos. So far, so good. But here's where React behaves differently in development mode, thanks to something called strict mode. Strict mode is a dev-only feature that helps catch bugs early. One way it does that is by intentionally rendering your component twice. It mounts it once, unmounts it, and then mounts it again just to make sure your code handles startup and teardown properly. Right? You can read more about it at this URL, but let's go back to code and see what's happening with our code. So let's see what actually happens in the first render. The app loads to-dos from local storage. Over here, it calls set to-dos with non-empty array. But remember, set to-dos or any set state operation is asynchronous. It schedules a state update or a second render, and React moves on to the next step. Before that update takes effect, the use effect that watches to-dos, this one, is executed. At this point, to-dos is still the default empty array. So it writes that empty array back to local storage, wiping out all of our saved to-dos. React is now preparing to re-render with the real data. But instead, React unmounts the component because, yeah, you guessed it, it's in strict mode. That scheduled state update, gone. Cancelled when component was destroyed. Then React mounts a new instance of your component. This new version reads from local storage again, but by this time, since local storage.set item was synchronous, your saved to-dos are gone. They have been replaced with an empty array. So they are loaded. Now it calls set to-dos with an empty array. And that updates goes through. So even though set to-dos non-empty array was called initially, it was part of a component that no longer exists. So the update never made it to the screen. In case you are wondering, isn't that non-dependency array only supposed to run once? Because that's the definition of it, right? Yes, in production it does. But in development, React 18's strict mode runs all use effects, including this one, twice on purpose. Why? To help you catch bugs related to side effects, stale state, or cleanup logic. So that's why our app loaded the correct data, then immediately saved the wrong data before it had a chance to finish updating. To solve this, we use a simple trick, useRef. We track whether it's first render, and if it is, we skip the save. We are trying to solve the strict mode issue here, but it also makes sense otherwise, since we are loading saved data here, so immediately storing the same thing back in second use effect doesn't make sense anyway. That way we give React time to properly load and apply the real to-dos before saving anything back to local storage. This avoids overwriting real data with an empty array, and everything works as expected even in strict mode. So let's apply this change. Alright, now the first time the component runs, we avoid saving too early. From the second render onward, we save normally only after we are sure that real data has been loaded. No more accidental overrides, and everything will work as expected. So let's try it again. Okay, what's wrong? Oh, we never imported useRef. Sorry about that. Here we go, right? And if I do a reload this time, everything works. All of our tasks are back just as we left them. That's because now we are correctly waiting for local storage to load and only saving after that. And if you ever see this use effect run twice in development, don't panic. It's React helping you write more predictable code. So let's go what you have learned so far. An empty dependency array use effect runs after the first render and may run twice in development due to strict mode. If you load state in one effect and save it in another, be careful. You might accidentally override your saved data. Use useRef to skip saving on the first render. This ensures you only save once the data is real. During all this explanation, I assumed that you already know about useRef, but if you are not sure, useRef is like a box that holds a value across renders, but changing it doesn't re-render the component, which makes it perfect for flags like this. And you access the data using the .current property. Alright, that section is complete. So far we have added task completion with a check mark, allowed deleting tasks, and saved everything using local storage for real persistence. In the next section, we'll style our app to make it clean and modern, and you'll learn how to work with CSS in a React project. So our project is going great. At this point, our app is fully functional, but it looks ugly as anything. So now let's make it look a bit nicer. We'll add some basic CSS to style the layout, spacing, and buttons so everything looks clean and modern. All the styles will go in the app.css file that we created for us. So I'm going to get rid of all the regenerated app.css contents and we'll replace it with our own. All right, we need to do one little change to our content and then I'll explain everything I did in the CSS file. Too much, is it? Well, let's see once I'm done and show you the result. Then you'll be the judge. So, but first let me explain what I did. So we start with a basic reset using the star selector. This removes any default margin and padding that browsers add to elements, and it sets box sizing to border box, which makes layout calculations much easier and more predictable. Next, we style the body. We set a clean sans serif font, give the background a light gray color, and use flexbox to center everything horizontally. We also add padding around the edges to prevent the app from being squished to the corners. Now on to the main container, the app class, which is applied over here on the top level div. This gives our app a white background, rounded corners, and some internal padding. We set a max width so the app doesn't stretch too far on larger screens, and we add a subtle box shadow to give it a card-like appearance. The heading is centered, spaced down from the top, and given a black color for good contrast. The input container uses Flexbox to place the input and add buttons side by side with a gap between them. We also add space below it so the form doesn't touch the list. The input itself stretches to fill available space, has clean padding, a readable font size, and a soft border. The add button gets a bright blue background, white text, and rounded corners. It also uses align self stretch, which makes it match the height of the input field. This gives a nice balanced look. On hover, it changes to a darker blue to show it's interactive. Next is the styling of to-do list. First, we remove the default bullet points by setting list style to none. Then for each list item, we give it a light background, rounded corners, some vertical padding, and flex layout to space things out. Importantly, we remove the right padding so the red delete button aligns perfectly with the add button above. This tiny detail makes the layout look a lot more polished. Finally, the div that we just added, the to-do buttons, that container holds both the green check and red delete button. We use Flexbox again with a small gap to separate them. Each button has smaller padding and font size than the add button, so they don't feel oversized. The check button is green and the delete button is red, instantly signaling their purpose. And that's it. The styling keeps everything clean, balanced, and intuitive, while also teaching you some solid layout and design practices. So we have saved the file. Let's go to our layout and see that in action. And you can see for yourself the app now looks way more polished. Let me add another task. Here we go. I think at this stage our app looks great, works like a real usable to-do list. Alright, amazing job. You have just built a complete to-do app using React hooks, controlled components, dynamic rendering, local storage for persistence, and clean modern styling. This is a perfect project. It shows that you truly understand the core of modern React. If this tutorial helped you, please give it a like. It really helps the channel. Leave a comment if you want me to expand this into a full stack version or maybe add a dark mode or filter functionality. Not to forget, we have a full playlist on building a full stack task manager app from scratch without writing any code by hand using AI assistants. Also consider subscribing for more beginner friendly web development and AI tutorials. Thank you so much for watching. Goodbye.